Hello friends, today we are going to talk about a new section, series. Okay, before we talk about the type of series, we have to know a word, sequence. Okay, it is a succession of terms formed according to some fixed rules. Okay, and next one is series. What is a series? It is the sum of a sequence. Okay, if we see, as for an example, sequence, we tell the terms are u1, u2, u3, like that. So the series would be u1 plus u2 plus u3 plus, it goes up to what's number. Okay, then another thing is the different on series. Okay, or the sequence. Okay, we'll get into sequence. So there are main two types of sequence we are going to look. Okay, the first one is finite sequence, and the second one is infinite sequence. Okay, you know what's the meaning by looking at the heading. Finite sequence contains specified numbers of terms, and for example, we will write 2, 4, 6, 8. Okay, that's a finite sequence. It has only 4 terms. An infinite sequence contains an unspecified number of terms. It will goes up to infinity. That we cannot finite the terms. So if we take the same example, we can write 2, 4, 6, 8, and it will goes up to in dotted lines. Okay, from finite sequence we will get finite series. That means the sum of the finite sequence. And from infinite sequence we will get infinite series. Okay, that is the basic thing we have to know about series and sequence. After that, we are going to talk about arithmetic series or arithmetic sequence. Okay, it can be series or sequence or progression, anything. And the second one is geometric series. Okay, so first we will talk about arithmetic series. We know arithmetic sequence. Before we know about the series, we have to know about the sequence. Okay, in this sequence it will have a constant difference. So the sequence with a constant difference called as arithmetic sequence. Like we use our numbers 1, 2, 3 or 2, 4, 6 or like that. It will have the equal difference in the consecutive terms. So in general form we can write them as a and a plus d and a plus 2d. Likewise, we can write them. If you see, the difference between the two consecutive terms would be same. These are equal. Okay, so like this, these are called as arithmetic sequences. Here a and d, okay, are constants, and a is the first term and d is the common difference, or that constant difference. Okay, from that we will get into the arithmetic series. We know what is a relationship between sequence and series. The sum of the sequence is series. So if we write the series for the above function, it can be written as a plus d plus a plus 2d. Likewise, so if we write for the nth one, so it can be given in the form, here see, for the first one we don't have the common defect d constant, so anyhow the first term will come, so a. So if we see the third one, we will get 2d. It means 3 minus 1. So it will be the nth term will n minus 1 d. So it is the equation for the nth term of an arithmetic sequence. Okay. So next one, we have to know how to do the sum. How to take the sum as an equation for that. So we can get those equation by two methods. So the first method is, we will write the sum of n terms, can be Sn. Okay, the sum of n terms can be written in this notation. So that is equal to number of terms into the addition of first term and the last term by 2. We have to add the first term and last term and divide them by 2. So this is the equation for this is one method to find the sum of n units. So if we substitute the values here to find the general form, so number of terms are n, and the first term will be a, and the last term is n, so n term is a plus n minus 1 d. So we have to add that with a. And we have to divide them divide the whole thing by 2. So if we write the general form, Sn is equal to n by 2 2a plus n minus 1 d. Okay, this is the general term of arithmetic series. Okay, we can do it in another way. We can prove that we can. So for that, we have to write the sum first. So Sn is equal to a plus d plus a plus 2d. Likewise, and the last two terms can be written as a plus n minus 2d, and the nth term, this is the n minus 1 term. So the nth term would be a plus n minus 1 d. Okay, so here I'm going to we have to name this as a equation number 1. So in the next thing, I'm going to rewrite the equation in the reverse form. Okay, so here I'm going to write Sn is equal to, the last term would become as first one, so a plus n minus 1 d plus a plus n minus 2 d. Likewise, it will be end as a plus d. So here I will write the last two terms, so a plus d and plus a. So this is our second equation. So we have to name it as number 2. So now I'm going to add these two equations. So 1 plus 2, that is equal to, here you have to note that we have to add the corresponding terms only. So if there is a first term and in the second first term in the second equation, first term in the first equation, so we add, we will get 2a plus n minus 1 d. And if we add the second term and second term, we will get as we will get the same answer. See, a plus a is 2a plus n minus 2d plus d is equal to n minus 1d. It will goes up to, if you see, if you add the last two together, you will get the same equation. So 2a plus n minus 1d. So if you see that if there's n terms, you will get sorry, I forgot to put a 2 here. So because Sn plus Sn is 2Sn, so 2Sn is equal to, there if you have n terms, there will be a n times of 2a plus n minus 1d. So if we get into the general form, sum of n unit is equal to n by 2 into 2a plus n minus 1 d. Okay, that is our, see, we are having the same equation for the sum of arithmetic series.